this video, I will be walking through an AI-powered semantic resume matcher that I recently built using FastAPI Gemini PostgreSQL with pgvector, Redis, Docker, and AWS. The goal of this project is to improve how resumes are matched with job opportunities by understanding meaning instead of relying only on the keywords. Let's discuss the problem statement. Traditional job search systems rely heavily on keyword matching. Because of this, relevant candidates can sometimes get missed if their resume don't contain the exact keyword mentioned in the job description. For example, a candidate might have experience with Docker and Redis, while the job description mentions containerization and caching. The intent is similar, but traditional keyword matching may not recognize that. This is the problem that I wanted to solve. Let me quickly show how the application works. So this is our user interface where we can upload the resume. So let's say a user uploaded their resume. So I have uploaded my resume here. Now the system processes the document, generate embeddings, retrieves relevant jobs, applies re-ranking, and return the most relevant recommendations. Now, from a user perspective, the workflow is simple, but behind the scenes, there are an entire retrieval pipeline powering these recommendation systems. So, as you can see here, we have all the relevant resume that is matching the resume that I have uploaded. And you can see it is also have the semantic rank as well, and how much percentage it is matching. Look at the architecture. The workflow starts with when a user uploads a resume. First, the PDF content is extracted and then converted into the plain text. The text is then converted into embeddings using Gemini. Embeddings are numerical representations that captures the meaning of the text, and to improve the performance, embeddings are cached using Redis, so the system doesn't need to regenerate them repeatedly. Next comes the retrieval layer. Instead of relying only on semantic search or keyword search, I implemented a hybrid retrieval approach that combines both and then this helps balance the contextual understanding with exact keyword relevance. The retrieved results are then passed through an LLM-based re-ranking stage where Gemini evaluates the overall relevance of each job, and finally the system returns the most relevant job recommendations to the user. Before building this project, I thought AI was mostly about generating answers. But while working on this system, I realized that retrieval and ranking are often equally important. Through this project, I explored concepts such as embeddings, vector search, semantic search, hybrid retrieval, Redis caching, and LLM based re ranking. These concepts are commonly used in modern AI retrieval systems and recommendation engines. The frontend is deployed on Vercel and the backend runs on AWS EC2 and is containerized using Docker. Postgres with pgvector is used for storing structured and vectorized data, while Redis handles caching. This setup allows me to deploy the entire system end to end in a production-like environment. Building this project helped me understand that modern AI systems are not just about generation, they are also about retrieving, ranking, and delivering the right information efficiently. Thank you for watching.